In today's session, we are going to learn how to solve problems on SFD and BMD, that is shear force and bending moment diagram. So I will start with first problem for simply supported beam. Here the diagram of the beam is given. So here first I will draw free body diagram for beam section. So at point A there is reaction force RA and at point B there is reaction force RB. Now this type of problem we are going to solve in 3 steps. The first step will be to calculate values of support reaction. Now here while calculating the support reactions, I use condition of equilibrium, and the first condition is summation Fy is equal to 0, that is summation of all vertical forces is 0, where upward forces treated as positive and downward forces treated as negative. Here I am not using summation Fx is equal to 0 because there are no horizontal forces acting on this beam. Now here if you see RA and RB, both reaction forces are acting upward, so they would be positive, and two forces which are acting downward, which is treated as negative. So I can write RA plus RB minus 5 minus 7 is equal to 0. Therefore RA plus RB is equal to 12. So here I will give this as equation number 1. Now next I use the second equation of equilibrium, that is summation of moment. Now calculating moment, either we can take moment at point A or at point B. If I am taking moment at point A, that is summation of moment of all forces at point A is equal to 0. And here my sign convention would be clockwise movement as positive and anti-clockwise movement as negative. So for taking movement at point A, I fix beam at point A. Now here 5 kN load will be pushing this beam towards downward, so it rotates the beam clockwise. And for clockwise movement, I will treat this as plus 5 kN. Now as per decided, movement is always force into distance from fixed point. So plus 5 kN is the force into 1.5 meter is the distance from fixed point. And here 7 kN load will be pushing this beam towards downward, so it rotates beam clockwise. And for clockwise movement, I will treat this as plus 7 kN. And the movement is force into distance from fixed point. So plus 7 kN is the force into 3.5 meter is the distance from fixed point. Now here reaction force RB will be pushing this beam towards upward. So beam rotate anti-clockwise from fixed point, and for anti-clockwise rotation, I take it as negative and multiply this force by distance, which is 5 meter from fixed point. So these are the moment which we have. So therefore by calculating this, I will get the answer of RB as 6.4 kN. Now I put this value of RB in equation number 1. I will get the value of RA as 5.6 kN. So this is the first step where I calculated values of support reaction, that is RA as 5.6 kN and RB as 6.4 kN. So here we complete step number 1, that is calculation of support reaction. Now step number 2 is shear force calculation. In case of shear force calculation, we need to have the sign convention. So here sign convention is upward forces treated as positive and downward forces treated as negative. Now in this problem there is simply supported beam, and we should start shear force calculation from left hand side. That is, we are using left hand side as reference and going on calculating values of shear force. So first to calculate shear force at point A, I take the section of left of point A, that is SF at A to the left, because here are no forces on left hand side, so SF at A to the left side is equal to 0. So to draw shear force diagram, I will draw a horizontal reference line of 0 kN shear force, and at the beginning of point A, that is SF at A to the left is equal to 0. So here I mark 0 value on reference line. Now if I go to the section of right of A, that is SF at point A to the right, then there is upward force, that is reaction force RA, which is 5.6 kN. So as per the sign convention, upward forces is treated as positive. So here the shear force is plus 5.6 kN. Therefore SF at A to the right is equal to plus 5.6 kN. Now here if shear force value is positive, we have to show it above the reference line, and if shear force's value is negative, then we have to show it below the reference line. And in this case, value of shear force at point A to the right is positive, therefore I mark vertical line of 5.6 kN. Now I am taking section to the left of point C, that is SF at C to the left. Then there is no load on beam between point A to point C to the left side, therefore shear force remains constant. That is, shear force at point C to the left is equal to 5.6 kN. Now there is no variation in shear force value, so make horizontal line with shear force value as 5.6 kN. Now I am taking section to the right of point C, that is SF at C to the right. Now to minimize calculation, here I have carry forward previous value of shear force up to point C to its left side, which is 5.6 kN, and when we move towards right of point C, then there is 5 kN downward force which is negative. So this will be plus 5.6 minus 5, and it gives me the value of shear force as 0.6 kN. Therefore, SF at C to the right is 0.6 kN. Now in case of value of shear force, it is positive, therefore I make vertical line of 0.6 kN. Now when I taking the section to the left of point D, that is shear force at D to the left, then there is no load on beam between point C to point D to the left side. Therefore shear force remains constant, that is shear force at point D to the left is equal to 0.6 kN. Now there is no variation in shear force value, so make horizontal line with shear force value as 0.6 kN. Now I am taking section to the right of point D, that is SF at point D to the right. Now here I carry forward previous value of shear force up to point D to its left side, which is 0.6 kN, and when we move towards right of point D, then there is 7 kN downward force, which is negative. So this will be plus 0.6 minus 7, and it gives me the value of shear force as minus 6.4 kN. Therefore SF at D to the right is equal to minus 6.4 kN. And in this case, value of shear force at point D to the right is negative. Therefore I make vertical line of minus 6.4 kN to the point which is below the reference line, because shear force value is negative. Now when I am taking section to the left of point B, that is SF at B to the left, then there is no load on beam between point D to point B to its left side. Therefore shear force remains constant, that is shear force at point B to the left is equal to minus 6.4 kN. Now there is no variation in shear force value, so make horizontal line with shear force value as minus 6.4 kN. Now when I am taking section to the right of point B, that is SF at B to the right, then I carry forward previous value of shear force up to point B to its left side, which is minus 6.4 kN, and when we move towards right of point B, then there is 6.4 kN upward force, which is positive. So this will be minus 6.4 plus 6.4, and it gives me value of shear force as 0 kN. Therefore SF at B to the right is 0 kN. So here I mark 0 value on reference line, and in shear force diagram, whatever the portion draw above the reference line, I will show this by plus sign, and the portion draw below the reference line, I will show this by negative sign. So here I have completed shear force diagram. Now the third step is calculation of bending moment. So whenever you solve the problems, you should remember these conditions. And here for simply supported beam, the condition is at the support bending moment will be 0. So bending moment at point A and at point B will be 0. So first I'll say that bending moment at point A, that is Bm suffix A, is equal to 0 and Bm suffix B is equal to 0. Now in case of bending moment calculation, our sign convention is for sagging effect of beam we treat it as plus sign, and for hogging effect of beam we treated this as negative sign. So for bending moment diagram, here I draw horizontal reference line of bending moment 0, and I mark point A and B whose bending moment value is 0. Now to calculate bending moment at point C, here I will start from left end of beam, because there is only one force, that is 5.6 kN, which is upward force, and due to this force the effect on beam is sagging effect, and for sagging effect our sign convention is plus sign. So the force is plus 5.6 kN into distance from point of action of force, that is 1.5 meter. So the value of bending moment at point C is 8.4 kN meter, and here I will mark 8.4 kN meter above the horizontal reference line of bending moment diagram. Next is bending moment at point D. Here to calculate bending moment at point D, you can start either from left end or from right end of beam. Here I will start from right side because there is only one force, that is 6.4 kN, which is upward force, and due to this force the effect on beam is sagging effect, and for sagging effect our sign convention is positive sign. So the force is plus 6.4 kN into distance from point of action of force, that is 1.5 meter. So the value of bending moment at point D is 9.6 kN meter, and here I will mark 9.6 kN meter above horizontal reference line of bending moment diagram. Now since I can see this bending moment diagram is drawn above the reference line, so whatever I have drawn, all the values of bending moment is positive. I will show this by plus sign. So here we have completed shear force and bending moment diagram.